I'm giving a geometric definition. That means it's actually in the plane. It's one of the definition of a tangent to a plane is that it's perpendicular to the normal. Yeah. So you're like, but you didn't tell me what the normal to the plane was. So,
yes, you did.
Did I?
Sort of. You gave us the information.
I gave you two tangent vectors to the plane, right? Two non-collinear tangent vectors to the plane. That suffices to determine a normal. Actually, there's two that you could choose. You could either choose A cross B or B cross A. Okay. Indeed, there are always infinitely many choices for the normal, corresponding to the fact that you can always take the equation for a plane and multiply by a non-zero number. It's the same solution set. It's the same plane, and yet it has a different normal. So to choose a specific normal to a plane, you have to make some sort of ad hoc convention, like you have to have a normal of length 1, and you've got some way of choosing what side of the plane you're on. That would be called an oriented plane. An oriented plane is one in which you know which way is up.
Those are used for computer graphics.
Ah, yes, computer graphics. No danger of that today. Well, I guess earlier that was sort of computer graphics, but not really. Not the exciting kind. Do we have a course in computer graphics?
Probably not.
We should though, right?
Yeah.
Oh well.
Just linear algebra.
Yeah, if you were an honors student and you wanted to do like an honors petition in linear with computer graphics, I'd certainly allow it. Let's see here. A cross B. Not to give you any ideas. A cross B, supposing I was teaching linear. Supposing I wasn't fired, that sort of thing. But let's see here. You never know. I mean, there's any number of politically incorrect things I say in a given semester. I might be on the wrong side of the line at some point. I don't know.
Well, I mean, you can always go to the bookstore and buy the T-shirt that says politically incorrect since.
Oh, really?
Like forever.
Then you have to wear a different shirt.
Why are we supporting Bill Maher's show? Oh, I'm sorry. That's too old for you guys. But okay, I digress. So A cross B, we already calculated over here. It's what? It's minus 21, minus 8, 7. Well, that was convenient. So we know that this is a normal. And so we've got what? This is my A. This is my B. This is my C, quote unquote, right? I gave you a base point, right? That was given. And so what do we have left to do? Yeah, just write it down, right? We can write down the equation. So, thus, P has equation minus 21 times x minus 3 minus 8 times x, y minus 4 plus 7 times z minus 5. And I'll put the 0 over here since it's interfering with my picture. There you go. That's the equation of the plane. That wasn't too bad, was it? There are all kinds of different ways of coming at these problems. Let me show you the other standard problem, and this will be it for today. So the other standard problem is something like this. Suppose you got a plane, right? And you got 3 points in it. Let's say 1, 1, 1, 7, 6, 5, and over here I'll do 0, 1, 0. So find the equation of the plane which contains these 3 points. Right. I'm sure there's some kind of formula that you could just plug it into, but that's not the point here. I want to think geometrically. So here's how I think about this problem. I just think about vectors, right? I think about one of these things being my base point. I'll use 1, 1, 1 as my base point, right? So to get two tangent vectors to the plane, I just think about the displacement vector from 1, 1, 1 to 7, 6, 5, and from 1, 1, 1 to 0, 1, 0. Is this picture geometrically reasonable? Like, is there some coordinate system where these points are related as such? No, I don't care. It doesn't matter. This is a heuristic for setting up the plane. Like I don't think I'm going to get into trouble by not drawing the picture according to the standard XYZ coordinates. So this is just a guide. So if you're trying to see this in your mind, how these points relate, I'm not even thinking about it. So it may be totally like impossible to come up with a coordinate system where these points are related in this way. And yet I think we're going to be okay.
Well, you'd only really run into that problem if those points happen to be collinear.
Yeah, a collinear would be bad. If I do that, if I say find the equation for a plane of 3 collinear points in the test, you know that I was in a hurry writing the test, pretty much. So anyway, A is what? B is what? 6, 5, 4. So that's 7, 6, 5 minus 1, 1, 1. And then B, I'll write the work down for B. B is 0, 1, 0 minus 1, 1, 1, which is what? It is minus 1, 0, and minus 1. Then to find the normal, well, our friend the cross product helps us out here. So we just have to calculate the cross product of A and B, which admittedly is a bit of a hassle, but we can do it. We're going to use that for our normal. So A cross B equals to, 6, 5, 4 crossed minus 1, 0, minus 1, which is minus 5 minus 4 plus 6 plus 5, which is minus 5 to 5. Now, I just did that in my head, so I doubt myself. All right, I'm going to check. Is the dot product of A cross B and A 0? Minus 30 plus 10 plus 20. Woohoo! Is the dot product of A and A cross, is B and A cross B have a dot product of 0? 0. Wait a minute. Oh, that's not B. Yeah, you got to make sure you check the right vector, otherwise it doesn't go well. So 5 minus 5. Woohoo! Okay, so yes, today I can do cross products in my head. That's not every day. But I'm just using the definition. So there's your normal, and therefore, minus 5 times x minus 1 plus 2 times y minus 1 plus 5 times z minus 1 equals to 0 is the equation of the plane we're after. If you don't understand that, it's because you have not yet internalized the thing I told you 10 minutes ago, which is understandable. This is the definition of a plane in scalar notation. Honestly, my definition of the plane is over here. I like this definition. But, pragmatically speaking, this is very useful. You really need to think, you need to have the concept of that, and you need to have the memory of this. Anyway, that's all I got for you guys today, because I owe you some minutes from yesterday.
We're doing plane proofs, you probably want that one. We're doing plane drafting.
Yeah, it depends on the problem. But, yeah.